availability, and second law efficiency. What is the maximum reversible work? Can be done by a given mass in a given state. In the previous section, we developed expression for the reversible work for a given change of state for a control mass and control volume undergoing a specific type of process. For any given case, what final state will give the maximum reversible work? We had from previous minus the transient and there is also another question that what the final state will given the maximum will give the maximum reversible work. The answer to this question is that for any type of process, when the mass comes into equilibrium with the environment, no spontaneous change of states will occur and the mass will be incapable of doing any work. Therefore, if a mass in a given state undergoes a completely reversible process until it reaches a state in which it is in equilibrium with the environment, the maximum reversible will have been done by the mass. When the mass comes into equilibrium with our environment. No spontaneous change of states will occur. And the mass will be incapable of doing any work. Therefore, if a mass in a given state undergoes a completely a mass in a given state undergoes a completely reversible process until it reaches a state in which with the environment. The maximum reversible work will have been done by the mass. So with this sense we can have a ability is a potential for achieving the maximum possible work for achieving the maximum possible work. By the mass. If a control mass is in equilibrium with the surrounding, it must certainly be in pressure and temperature equilibrium with surrounding, that is at P0 and T0. At equilibrium with surrounding, it must certainly be at pressure, be in pressure and temperature equilibrium. With the surrounding P0 and T0. It must be also be chemical equilibrium with the surrounding also require that the system have zero velocity and minimum potential energy. zero velocity and similar requirements can be set forth regarding electrical and surface effects if these are relevant to the problem. Electrical and surface effects. The same general remarks can be made about the quantity of mass that undergoes a steady-state process with a given state for the mass entering the control volume. The reversible work will be maximum when this mass leaves the control volume in equilibrium with surrounding. This means that as the mass leaves the control volume, it must move at the pressure and temperature of the ambient or surrounding for a steady state process. With a given state for the mass entering the control volume. And also the exit with equilibrium. Process. The exit condition must be at surrounding state T0 P0. This means that as the mass reaches the control volume, it must be at the pressure and temperature of surrounding, with chemical equilibrium and with the surrounding and having potential energy and zero velocity at the previous. The mass leaving the control volume must be necessarily have some velocity, but it can be made to approach zero. Let us consider the availability from the different type of processes and situations that can arise and start with the expression for reversible work. Consider the reversible work expression. For that expression, we recognize separate contribution to the reversible work as one form heat transfer, another form from the flows, heat transfer, flow of mass, And finally, a contribution from the storage effect, that is change of state of substance inside the control volume. We will now measure the availability as the maximum work we can get out relative to the surrounding. Measuring the availability as the maximum work can be get out relative to the surroundings. We can get out relative to the surrounding. Starting with the heat transfer, we see that the contribution to the reversible work, heat transfer, from this term relative to surrounding, at T0 are phi dot Q dot J, which was the result which we found in the equation 10.1 also, which is W reversible HE heat engine this is now labeled as the rate of availability phi Q that equals the possible reversible work that can be extracted from the heat transfer. Rate of availability that equals the possible reversible work that can be extracted from the heat transfer. As such, this is the value of heat transfer expressed in work. expressed in work. We notice that if the heat transfer comes at a higher temperature Tj, the value availability increase and we could extract a larger fraction of heat transfer as work. This is sometimes expressed as the higher quality of heat transfer. So if the heat transfer comes at a higher temperature, Tj the value increased and the increase and we could extract a larger fraction of heat transfer as well. This is sometimes expressed as a higher quality of expressed as a higher quality of heat transfer one limit is a infinite high temperature for which the heat transfer is 100% availability. Availability of and another limit is the one limit, another limit, for which the heat transfer has zero availability. %. For which the heat transfer, shifting attention to the flows and availability associated with the sum. Those terms we like to express the availability for each flow separately and use surrounding as a reference for thermal energy as well as kinetic component of energy. Having a flow at some state the flow lives in equilibrium with the surrounding. So until now we talk about the heat transfer, reversible work or availability, and now we are going to talk about the flows and the availability. Next.